Okay. So, am I audible? My screen is visible. Kindly confirm me.
Yes, sir.
Yeah. Okay. So, in this particular, thank you, thank you. So, in this particular live session, we will discuss the solutions of week 9, and we will discuss briefly the things related to week 10 assignment for week 10. So in the first question, which is true statement true, so yeah, it can facilitate bidirectional power transfer, correct. Then it requires inductive filtered output. This is wrong actually. So this is A and D option is the only correct option that we will reevaluate the question for this one week 9. So that is there. It is only A and D option which is correct. I agree. Then the second thing, which is in a DAB, the question which is given over here, let us see the solution for that. So let me open this thing. Yes. So it is nothing but, this straight down formula we have to use, and we know that our P average maximum, this is our maximum, is nothing but V naught V in by 8 NL, 8 by 8 N L FSW. This you just equate it, and it is given that half of the maximum power, average power. So that you do that, and then finally you will get this equation. When you solve this equation, you will get these 2 degrees, and we have given that in the question that only the phase shift has to be kept less than 90 degree. So it is 26.28 degree, which is correct. If you put the terms in between 25 to 28, your answer will be correct. So this is the problem, second problem. Now comes the next problem, next question, where it is saying that the optimum value of magnetic flux density delta V for transformer is obtained using following conditions. So the condition is simple: differentiate the P total, which is nothing but summation of the P core and total winding copper losses, and make it equal to 0. So that particular expression will actually uh, give you the point at which your delta V is optimal value, and then you can equate that thing in the equation, in the P total equation, to obtain the minimum value of total power loss in the transformer. So that's why option A is correct. Then comes your question number 4. In question number 4, PCU total is given, P core is given, A, B and beta are the coefficient, and it is given that beta is equals to 2. So we have to find the optimum value of magnetic flux density. So for that, what you have to do is you have to do a simple thing, which is take the expression. This is P total by D del B equal to 0, and then which is nothing but summation of PCU copper and PCU core. Then you do it PCU, that implies my differentiation of PCU P copper loss versus, this is, let me write down, this is P total, PCU total. So our P core is nothing but it is given as uh, our P core is given as P delta B raised to power beta, and beta is given as 2, so it is nothing but delta B square. So this, when you differentiate with delta B, you will get minus 2A, sorry, this, when you differentiate this, you will get 2B delta B. So that what you will get for D P core by D, differentiation of P core with respect to differentiation of del B. And similarly for PCU total is given as, my value A by 1 by del B raised to power 2. So when we do the differentiation of that, we will get minus 2A and del B raised to power minus 3. This you equate, this both you should we have to equate. So when we equate both the things, we got this. So this implies my A by B is nothing but equal to delta B raised to power 4. That implies my delta B is nothing but A by 4 raised to power 0.25. So our option is, correct option is So correct option is nothing but B, which is shown over here. Then the question number 5. In question number 5, the inductor current waveform is being given, and you have to then draw the uh, your what you can say, your relationship. So in this thing we have V in greater than V naught. So V in greater than V naught means this particular slope will be positive slope. So that's why 1 equates to B. Second is V in less than V naught. So that means this slope, because at this point it is nothing but V in minus V naught by N, and if the V naught by N is greater than V in, then this slope will be there. So 2B, 1B, 2C, 1B, 2C, and the third one is V in equal to V naught. So this particular thing is a straight line. However, there is this particular curve we have shown. This is due to rise and fall of because inductor current will take some time to rise and fall because of that. But however, this kind of your waveform is also called as the flat top, because you have straight line which shows which is, it indicates that V naught is by N is equals to V in. So it is nothing but your flat top kind of transformer current, and or you can say inductor current, and that's when you will get V in equal to V naught by N. So that's the correct option is B, which is shown over here. Then in the sixth question it is given that we have also given a phase shift between one of the half bridges in one of the full bridges of DAB. So in DAB we have two full bridges, and in those two bridges is one of the full bridge in those two full bridges, one of the full bridges, out of the two half bridges we have given the phase shift between the half bridges. So what we will see is that we have some zero state, we have waveform like this. So and then course continues. So that means this is a period when because of the phase shift you will get the zero pulse. In case when there is no pulses, so from the output of the full bridge you will get waveform like this, I mean voltage waveform like this. But when we introduce the phase shift between the half bridges of the full bridge, you will start seeing a zero state in the output voltage waveform of full bridges. So that's why this is the option which is correct. See, in you may ask questions that obviously this option is not correct. The B and C option is not correct because you have one place you have not given the zero, what you can say, zero your 0 point has not been occurred. Only on one side it is been occurred, on the other side it has not been occurred. So that's why this D option is correct. Yes, Lokesh, you may go ahead. Lokesh, you have asked question.
Sir,
Hmm.
but in option D, in starting of the pulse, it is starting with on,
Yeah, yeah,
no
yeah, yeah.
sir.
You see this part.
But it should be in off, no
No,
sir,
no,
in
no, sir.
starting.
It is okay. It is okay. I mean, it is like this. Zero is there, and then it is starting. So it is like this. It is like this. It is going. It is going, and then it is there. So this zero indicates only this, both sides zero has been given. So obviously it is understood that initially it will be zero at the on the left side it is zero.
Okay, sir.
It is indicative of that. The moment I have drawn, the moment I have given here 0 and 0 here, it indicates that before rising of this particular edge, it could also be possible that your 0 will come over here, but you will have 0 before the rising edge, and you have 0 before the falling after the falling edge. So both sides your 0 has been introduced.
Okay, sir.
That is why I have given this side. On this side I have given, just to be indicated. If I would have stopped at this place, then I agree what you told, that I have not given any idea about whether there is zero or not. But here, since I've given this information, it itself indicates that there is a insertion of zero state before the rising pulse been has been started. Okay.
Okay, sir.
Then comes the question number 7. In question number 7, let us see the solution for that. Again, it is a straightforward question with the formula given over here. Here it is given 60 degree. So we have to take 60, I mean in terms of degree. So we have to do divided by 180 to get the phase angle ratio. So that's why we have done the phase shift ratio, you can say, which is 60 by 180 degree. This we have taken, and turns ratio is given as 2 raised to 4, which itself indicates is a np raised to ns, which indicates that my n value is nothing but 4 by 2. So that indicates my power average power is nothing but 1 kilowatt. Okay, when you put this thing in this formula, because n we know, L we know, frequency we know, input and output voltages we know, phase angle is given as or phase shift is given as 60 degrees. So that also we know. So that's why we have to just take the put the formula and we have to get it. Then in question number 8, again you use the same formula, a maximum average power, which gives V0 V in by 8 NL FSW. Input and output voltages are given. Your number of turns is given 1 raised to 4, so n equal to 4. Then these two values given, which gives the value 8000 watt, which is nothing but 8 kilowatt. So
Hello, sir.
yes,
Sir, but in that question, only the turns ratio is to be mentioned. So, in all theory, we are considering the turns ratio as N2 by N1.
so
So, we are turns. So,
N2
as
by
the turns
N1.
ratio is given, so
So you do N2
so
by
I
N1. No, it is all, see, the moment, see, either I can give turns ratio 0.5. If I would have given turns ratio 0.5, then it is understandable that I have to take n equal to 0.5. If I have given the things like this, it indicates that my number of turns on the primary is 2, my number of turns on secondary is 4. So that indicates my n is nothing but 4 by 2,
Okay.
which is 2.
Okay.
It is a common notation they used to do with the transformer. Explaining about the transformer.
Okay.
Okay. So this is what is question number 8, and I think these are all questions which are there. So in this assignment, question number 1, only one option is C option is not correct. We will reevaluate that by removing that option, and that's it for the things related to assignment number 9. Now let me see the assignment number 10. Again, in the assignment number 10, you will see a lot of what you can say, a lot of theory part is there. So a lot of theoretical part will be there. Again, first problem is directly, you have to see the lecture number 49. From there you will understand what I am trying to say over here. Then in question number 2, you can directly use the this relationship from this particular, in lecture number 49, you will see this relationship, like what is the duty ratio and how it reflect, how it indicates what can be the maximum current which the we can draw. So just you have to do that particular part. Duty ratio in percentage is given. So this D value which is given over here is in percentage. So that you have to see, and then you have to just calculate. Straightforward question is there. In question number 3, it is given that the current is been given. So from the current, you can then find out what will be the duty ratio. And once you know the duty ratio, you know that what is your cycle time. You know that your cycle time is 1 kilohertz. So you can then calculate the time for which the positive voltage level is been there. So if I tell, we know that in our PWM, I mean, already we know it is time period is nothing but corresponds to 1 kilohertz, and we have some point positive voltage level is there, and some time negative voltage level is there, and our duty ratio is nothing but, let's say this is the T on time and this is the T time, total T time. It is nothing but T on by T. And you can obtain this duty ratio from the things given in the question. Like it is given that 45 ampere correspond to that, what will be the duty ratio, and you know this T value. From there you can easily calculate what is the T on value, which is a time period for which the positive voltage level has been applied. And then you can solve this particular problem. I think it's question number, I think 1 2, let me see, it's question number 3. So it is nothing but question number 3. Using this thing you can do. Similarly, question number 2 also, you have been given duty ratio, and you know from the duty ratio you can extract I maximum just by the relationship which is shown in the table, 49, table number 49, which is shown. Similarly, you can also see in the lecture number 50, I have drawn while discussing related to recap part. I have already shown how will be my duty current with respect to duty ratio varies in I think slide number, if I saw slide number 49, 50. Let me open up my 50, slide number 50, and then I'll share my screen again. So you can see in my slide number 50, in lecture number 50, I have discussed this part, how my with maximum current, how my duty ratio varies. So using this particular thing, you can able to obtain what will be my I have given the current level, what will be my duty ratio, and from duty ratio you can back calculate what will be the time period for which the positive voltage level is been applied. So that you can easily get. Then in question number 4, this is our question number 4. In question number 4, I have given the PP circuit, and I have already explained how you can obtain the voltage at this point. This is where the thing, you know, because this is the same pin, so this is the same circuit which I have. So I want you to calculate voltage between this PP pin with obviously with respect to protective earth. So you have just a simple resistive divider circuit, 5 volt. I mean, you can just trace down. I have already discussed in the lecture. You can see, I think in lecture number 48 I have discussed. So you can follow the same step and you can obtain the circuit. You have 330 ohm, you have 4.7 kilo ohm, and you have R6. R6 value is already given. So you can, using that thing, you can able to calculate that. Then comes the question number 5. In question number 5, all the things related to inductor is been given, and you can directly use this formula. We have already included in the step number 2 of the inductor design, where we have to calculate the length of the air gap. That straight down the thing, we have to take the formula. Here again we have assumed that area of air gap is nothing but area of cross section of air gap is nothing but equal to the area of cross section of the core, because we have assumed that our fringing of flux is I mean, the amount of fringing of fluxes are very less, or you can say are negligible, and maximum amount of flux is getting retained within the core itself. So that's why from there you can just put this formula. All the values is this value n value L value AC value from there you can easily calculate your LG straight down the uh, things. And then these are some of the true and false questions which you can obtain by going through the slides. I think this you will understand by going through 50th slide. This you will get 48, 49. This you will get in 48. I think this part you will get in 50. Then again this is from 46, 47, lecture number 46, 47 you can get. This particular part you will get question number 4. You will get from lecture number 48. This is again 14, 40 or 50 you can get 50 or 49, both in both the things I discussed. This you will again get 49, 50, and this is something you will get it from I think 49. So this is what you have to, you will get it from 47, and that is how you will able to solve all the problems in a week number 10 assignment. Then let me discuss some of the doubts which people have asked during this week. Okay. The question was, in the lecture, at one place I have used the terminology R equivalent to be nothing but equal to 4n square L leakage FSW. So how can we take this particular R equivalent? First of all, if I see the video, let me see the video. This is the part of the video. In the video, this R equivalent is not the equivalent resistance between A and B. I mean, it is the resistance. It is just the terminology which I have taken, and that terminology is nothing but N being tilde di by R equivalent, that I have taken. So that is what I just wanted to say in this particular problem. And this is what I wanted to. So it is just the expression which I have taken, and this, when you rearrange, you will get the expression something like this. Because if you see the relationship between di and IL, what you will get is, you will get V in by this particular expression. So this particular expression can be taken it as a resistance term, and V in, because V in is now referred to the secondary side. So from there we can directly take the relationship. I mean, we can assume that there is some term, resistance term, which has the relationship between which actually provide the relationship between the IL tilde and the NV in voltage. So that is what is I have taken and I have solved further. It is not the R equivalent between the point A and B. Then question number 2, yes, I have corrected. The C option is not correct. We will remove that option to be a correct option. Thank you, Ratnesh, for letting us know. Then the question number 3, in DAB, the primary and secondary side coils are magnetizing and power transferring coil. Yes, they are not acting as a output side filter. Yes, they are not acting as a output side filter. And I mean, I think he is referring to the same problem because uh, uh, to the, I think question number 1, he's referring to the same question number 1. No, the leakage inductance is acting as the power transfer inductance, and the magnetizing inductance is there to actually, I mean, is responsible to induce the voltage on the other side. Now, the thing is, there is no output side filter inductor is there, and we have, you can say, that is one way of looking into things, that the output inductor is being kept within, I mean, is being incorporated in the power transfer coil itself. That is one way of looking it, but it is just the notion, you can say. So, I mean, they are not acting as the output side filter. Definitely, they are not acting as the output side filter. They are they are acting as the power transfer inductor between. I mean, they have the something called, they have the something called, the transformer will have something called something like this. So this is my magnetizing part, this is my leakage. So this leakage acts as the power transfer inductor, or you can say is responsible to have the, you know, flow of control, or to have the control over the current which are flowing between the two voltage sources which are kept like this. So yes, they are not, you are correct, he is correct, they are not acting as the output side filter, he is correct. So this is what we have got 3 doubts in the last lecture. Apart from that, if you have doubts, you please ask me. I am happy to answer it. Any doubt related to lectures, related to coming lectures, which is there, I mean, related to the coming assignments, or you can say lecture number 45 to 50, or further we have also uploaded up to 55. Any questions, any doubts you have? If you wanted to say something related to course or something, you may go ahead and say. Okay, I think there is no doubt, so I can just stop the recording.